Alright, so we're asked to balance the following ionic equation. We've got the permanganate ion, the tin 2 plus ion. Now just be careful, tin has 2 ions on your electrochemical series. So there's tin 2 plus, there's tin 4 plus. There's a half equation for the tin 2 plus, and there's a half equation for tin metal. Okay, so that's another one where students get a bit confused sometimes, and they find the tin, but they don't realise that it's on there twice and they pick the wrong one. Plus H plus goes to Mn2 plus Sn4 plus H2O. Okay, so we're asked to balance it. And the way we balance it is by separating it out into its 2 halves. So we want an oxidation half and a reduction half. And we're looking for the thing that is present on both sides. So for example, if I start by looking at these two, what do you think's happening there? Oxidation or reduction?
Oxidation.
Oxidation, because it's actually losing electrons, but it's becoming more positive. Yeah? So it's becoming more positive because it has lost electrons. Okay, so you're happy that that represents oxidation? Let's now look to see, well, I'm not worried about the hydrogen ions and the water there because we know that they are used to balance. So they aren't the reagents or the reactants and products that I'm interested in. They will balance themselves as we go along. So the next thing I'm looking at is, well, I've got manganese here. So something must be happening in this neck of the woods. I've got the permanganate ion. And I might have to move that over here a little bit. And I'm forming the manganese ion. That's it. And so what we're going to do is go through our normal process. This one's actually on the formula sheet, but I'll show you how to work it out anyway. We start out by balancing our things that aren't water, or aren't oxygen or hydrogen. The manganese, it's already balanced. Then we balance our oxygens with water. I'm going to need 4 waters. And then we balance our hydrogens with hydrogen ions, so I'm going to need 8. And then we're going to balance our charge with electrons. My charge on the product side at the moment is +2. What I've got here is +6 -1. Yeah?
Shouldn't it be +8?
Sorry, +8. Yeah, great. Thank you. I can't do this complex math. So this then is equal to +7. But we don't want to bring it back to 0 because we need these 2 sides to match with charge. And so if I subtract 5, that will give me +2. So I need to then add 5 electrons on this side. Yeah? Is that all right? Now, and then we can do a second double check and check to make sure. And so +8 -1 -5 does equal +2. So that all works out. Now we need to do some very heavy maths to balance these, because obviously this is a little bit more complex than the balancing we've done so far. We need to find the lowest common denominator. What am I going to do to my top equation? By 5. What am I going to do to this one? By 2. Again, so we have to remember 5SN2 plus aqueous plus 16H plus 2NNO4 minus aqueous goes to 5SN4 plus aqueous plus 2NN2 plus aqueous plus 8H2O.
That's pretty long.
It's pretty long, and they get pretty long. Yeah. And so remember how initially we were asked to balance that equation, and so now this is that equation balanced. And we can see that it does match up with that original question, because we've got our hydrogen ions on the reactant side and the water on the product side. Okay. Any questions? No? Why are we doing this? What madness is this? Oh, hail the hypnotoad. I guess one more thing about that is, oh no, we'll do that in a minute. We'll just get on and do some questions now. I'm going to just explain why we chose the 5 and the 2. So if I bring my oxidation down here, okay? And I'm going to multiply it by 5.
Because the electrons. Yeah.
To balance it.
I love
Then I'm going to do my reduction. Oh, hang on, 2 and 16.
3 days.
And yeah, it's the electrons, and so the electrons must balance so that I can cross them out. Because remember, whenever we have the same number of anything on both sides of the equation arrow, we can remove them. And that's what you'll also find as you go on through these questions. You might end up with, say, 6 waters on this side, for some, and 10 on this side. And what you'll do then is you'll completely remove them from that side and just leave 4 waters on this side. Okay, so everything there is, anything that's present on both sides can be removed. And that's our idea here, is that if we balance these so that we've got the electrons, the correct number of electrons moving, because they have to go from the tin 2 plus to the permanganate, don't they? It's a transfer. So we have to transfer the same number in and out.